Hello, this is Bill checking in with Paul McWhorters Pico W homework on lecture 32, homework assignment number 32. And this is kind of a continuation of stuff we've been doing with the wireless, the W portion of the Pico. And we have been working on collecting data from a API web site and trying to parse that data and display it in a useful manner. And then after that, we added a display to that. And then this week's assignment was to add, a buzzer or a LED or something else to give it further usability, functionality, that kind of stuff. So anyways, here goes. I didn't really need this PMW to import. I didn't mix colors. I set up the RGB the same as I have shown in the past thing. The board's been set up. I haven't dismantled it, so all this stuff is the same. I intended to use the red pin to indicate that the barometer is dropping, the blue pin for a steady state, and the green pin for a rising barometer. The blue, it just bugged me, so I got rid of the blue pin. I just didn't add a duty cycle to blue at all in there. So essentially it displays red if it's falling and green if it's rising. Here's some stuff that's pertinent to this project, and it's gone through a few revisions. So this hit time and hit counter work out well for me debugging and seeing where stuff's going on. I print out everything under the sun, as you can probably see down here. Anyway, and the barometer timer, it checks for the barometer change or comparison every 20 minutes. I've dinked around with this program enough that, Paul said you don't want to hammer it by asking for stuff all the time. Even if you do hammer it constantly, the website only returns data every 10 minutes, and you can see this by checking the clock. This is what it is at the end of the while loop cycle, on this. So and that'll stay the same until it goes 20 minutes. So after that, we're going to be into the 6 o'clock or 6:04 range. Oh, that's another goofy thing. For some reason, it doesn't do like 6:04. It just says 6:04, which I live with. But it kind of bugs me. Anyways, here we go. Then you set up the network and do all that stuff. And then I'm zipping past my personal info there, password stuff. And here it is. It's waiting for the connection. And again, we have gone through this all before. When it's connected, it displays it's connected. There are multiple ways to get information from this openweather.org data. I'm using latitude and longitude. You can pick the city, you can pick your zip code, and that'll work. I'm not sure where this displays, but I tried it and it worked. I'm not sure where it gave data from. You need to get a API key, and this is actually cut off, so you can't see all of my API key. But once you do this, it comes back and you print weather, and this is the whole weather onion, so to speak, that we're dealing with. And it prints everything out down here. And that's what I use to go through and parse and see where the data is. Going through this, this is the stuff that I found interesting, and I was just testing to see what would go on, and then I largely cut and paste from this. Here, Paul took whatever units they use for the barometric pressure. I forget what it was in, but Paul changed it to atmospheres. I guess he likes atmospheres. I've always grown up with barometers in the house, and we always have had inches of mercury, and that's what the meteorologists on local TV reported in. So I figured out a conversion for that, and then after thinking with this a little bit, it's a pretty straightforward conversion. It's just atmospheres times 30, which I didn't quite ever know or think about to know. But anyways, I'm reporting mine in inches of mercury. The other thing I changed on mine is rather than display in degrees from 0 to 360 degrees, I changed that to a compass heading, and I split it up into 45 degrees for to check it with, and so there are 8 points on my compass. Here we're going. I'm picking the barometric pressure before it hits the wild true, so I have something to compare against. So this is the original barometric pressure. Then you can see within however milliseconds or however quickly it takes to get down 2 or 3 lines there, it grabs it again, and that's called bar new. So when you first turn this thing on, start it up, it's going to be steady. Excuse me, and it's going to be steady for 10 minutes because it won't return another data blast for 10 minutes. Okay, so anyways, this is kind of old, but I left it in there. This really serves no purpose other than helping me debug. Paul said you didn't want to keep hammering the thing all the time, and I actually had it so it would pick up the barometer new in there, and whatever. I didn't like it, didn't need it. You know, it picks it up whenever it changes up here, up here. But what I did do is I had the same timer code, and I compared it against beat timer or barometer timer, which is every 20 minutes. So every other time that it spits back data is where it does the comparison, and I did that just for comparative purposes, and you know, barometers don't usually move all that fast, so that's what I did. Then when you get that, I called the new barometer timer, the comparison barometer time is, or data is bar comp for compare. Then after that, we changed bar old to bar new. Bar new is bar comp. And then I have this counter, and again, that was really for debugging and for me to watch the program and see where it was at. Then here's where we mentioned all that wind from the north, you know, the eight points there, and it displays, keep going down, this print stuff, none of this stuff needs to be in there. I just print it to have it, and it doesn't actually show up on the displays. This was an important part for me. It's this part down here, and that's what I kept track of for debugging and watching things go. So anyways, here's screen 1 from the OLED. It displays the city. It displays line 2 displays the time and date. Then it displays the temperature in Fahrenheit. Then it displays the wind speed, concatenated miles per hour, so we have the units on there, and that's at 0.36, the 0 point and the 36 line, so to speak, which turns out to be line 4 in this. And then the weather description, you go down 10 more and you can print another line. And then I had a sleep for 5 seconds just so you can kind of see it before it moves away. Then screen 2 is just barometer settings, where I do the barometer reading in millimeters of mercury. And then it goes through the comparison point, and it will display that it's either steady if barometer new equals barometer old, and you can see the duty cycle here on all of them is 0. As I mentioned earlier. And then if the barometer is dropping, if bar new is less than bar old, then I light up the red RGB section of the LED. If that's the opposite and the barometer is rising, then I light up the green. And that's pretty much the program. And unfortunately, the barometer hasn't changed during this presentation or my homework, but hope you guys had fun with it, and we'll see you on Tuesday, but that's my homework.